Hi, everybody. All right, so I have been asked to do problems number 273 and problem 289 from section 1.5. Oops, I forgot to put that on the top here, so section 1.5. So we are trying to use the logarithmic rules and expand this out. It is a technique that will come in handy when you get into integration later, particularly in Calculus 2. So, log base 5 of the square root of 125x y to the third. Now remember that a square root is really to the 1/2 power. And I'm sorry the voice is in the background, but the 1/2 now gets multiplied by each of the exponents here. I'll be back in just a second. All right, I'm back. Sorry about that. All right, so the 1/2 will get multiplied by the exponent of 1 on the 125, the 1 on the x, and the 3 on the y. So we end up with 125 to the 1/2 power, x to the 1/2 power, y to the 3/2 power. Now somebody might ask, could I have pulled the 1/2 out in front? And yes, you certainly could have. And then just be aware that you need to put parentheses around the grouping all the way through. All right. Now, this becomes, because multiplication in a log is addition of the logs. So log base 5 of 125 to the 1/2 power plus log base 5 of x to the 1/2 power plus log base 5 of y to the 3/2 power. These multiplications inside the argument of the log becomes additions outside the log. All right, now the half comes in front, the half comes in front, and the 3/2 come in front. Now, this piece right here, you need to ask yourself, 5 to what power is 125? Well, 5 to what power is 125 is 3. 5 to the third power is 125. And so this part here becomes 3. You have 1/2 times 3 plus 1/2 times the log base 5 of x plus 3/2 times the log base 5 of x. So now you have 3/2 plus 1/2 log base 5 of x plus 3/2 log base 5 of y. So you might see the following occur. You would see the 3/2 and the 3/2 get put by each other with the 1/2 here. And then they would factor out a 1/2 out of all of those. So you would have 3 plus 3 log base 5y plus log base 5 of x. And that is what you would end up with if you had initially taken the 1/2 here up at the beginning and just put that out in front. But remember, it belongs to each of the components. So I wanted you to see this before this, because you got to recognize that that 1/2 really belongs to all three components. Okay. All right. Now on 289, we're trying to solve for x. The natural log of the square root of x plus 3 equals 2. All right, well, that's a square root, so that's a half. It'll come out in front. So I have 1/2 the natural log of x plus 3 equals 2. I'm going to multiply both sides by 2, and then I'm left with the natural log of x plus 3 equals 4. All right. Now remember that the inverse of the natural log is e. If it's the inverse of log base 2, it would be 2. The inverse of log base 5, it's 5. So I'm going to raise each of these, or make both of these, the exponent of e. So I have e to the natural log of x plus 3 is equal to e to the 4th power. All right. What happens here is that effectively they cancel. That's not quite the right terminology to use. They're the inverses of each other, and because they are the inverses of each other, the argument comes out. Okay? Well, you have x plus 3 is equal to e to the 4th power. We're going to subtract 3 on both sides, and we get x is equal to e to the 4 minus 3. And we should check that answer, plug that back in right there. And so you have the 3 plus the 3, they get rid of each other, so then you have the square root of e to the 4th power, so you have the natural log of e squared, and it does work out to give you 2. I hope that helps.